Okay, so method 3, this idea of rationalizing, is going to be a good tool to use when the function that you're analyzing a limit of has a rational or a radical that's square root embedded in it. Okay, so before we get into this process, I want to show you why direct substitution doesn't work. Right, if we evaluate right off the bat at x equals 0, we're going to get the square root of 0 plus 1 minus 1 all divided by 0. And we see that we're running into that problem, right, again, of division by 0. And that's driven by the fact that there's just this lone x in the denominator. So we need to do some algebraic work to try to get rid of that x in the denominator. And at this point, I do see an x in the numerator, but it's inside the square root. So I want to think about how could I algebraically manipulate this to get rid of this square root. And we're actually going to rely on utilizing the difference of squares property. So if I take this quantity, the square root of x plus 1, and I multiply that to the square root of x plus 1 minus 1, I'm going to actually end up canceling the square roots, and then I'll have these guys squared as well. And I'm going to go ahead and actually show you all of that work, but I want you to know that this isn't a random choice over here, right? I didn't just randomly choose to multiply by the square root of x plus 1, although it may feel that way since I haven't shown you how this kind of continues. So I haven't done any direct substitution. All I've done is some manipulation, so I need to keep the limit notation. And I can say that this is the same thing as the limit as x approaches 0 of, I'm going to go ahead and multiply this out, right? If I take the square root of x plus 1 and multiply it to the square root of x plus 1, I get the quantity x plus 1. If I multiply the square root of x plus 1 to positive 1, I get plus square root of x plus 1. If I multiply negative 1 to the square root of x plus 1, I get negative square root of x plus 1. And then finally, I get negative 1 times 1, and that gives me negative 1. In the denominator, I'm not going to worry too much about that simplification just yet. All I'm going to do is write to myself that I'm taking x and multiplying it to the quantity square root of x plus 1 plus 1. Okay. Now, it kind of looks almost worse than it was before, and I totally recognize that. But there's a little bit of simplifying that can happen, right? I notice here that I have a positive square root of x plus 1 and a negative square root of x plus 1. So those will cancel. And then I also have a plus 1 and a minus 1. So those will cancel. So that kind of crazy work that we just did in that one line leaves us with the limit as x approaches 0 of x. It's the only thing that remains from the numerator that didn't get canceled out, divided by x times square root of x plus 1 and then plus 1. And you'll see maybe now why I chose not to distribute that x in, because I see that x is a common factor between the numerator and the denominator, and I get to cancel those out, right? That cancellation leaves me with the limit as x approaches 0. I divided x into x one time, and then we have the denominator still as square root of x plus 1 and then plus 1. Before we move on, I want to make sure that you guys are seeing the fact that I have not dropped that limit notation at any step yet, right? I haven't actually plugged in my 0. I haven't done any direct substitution, so I'm not yet ready to drop the limit sign. But it looks like here, if I plug in 0 for x, that we'll get something that actually makes sense, right? That isn't division by 0. So now in this blue step, now that I'm plugging in 0 for x, I can go ahead and drop the limit. Right now I'm trying out that direct substitution strategy to see if I can evaluate this limit. So I get 1 over square root of 0 plus 1 plus 1. And that gives me 1 over the square root of 1 plus 1. I know that the square root of 1 is 1. And if I add that with another one, I get 2. So my denominator is that 2 and my value is 1/2. That tells me that the limit as x approaches 0 of square root of x plus 1 minus 1 over x is equal to 1/2. All right, you have 2 practice problems here. Very similar, you want to use this video and the guided notes to help you through practice 13 and 14. And when you're done with those, go ahead and check your work.